Let's investigate some handy bipolar junction transistor circuits. These are circuits you should recognize. They're handy ways of doing things. They're similar to little building blocks that you can use for various different things, and yet in themselves they're also useful. The first transistor circuit we're going to look at on the top here is a relay driver. This relay driver is usually used when a microprocessor is trying to turn on a switch that will handle much more current than the microprocessor MOSFETs will handle. And so we use a thing called a relay. It's actually an electromagnet that pulls in a switch here. And so what happens is when you draw current through the electromagnet here, it closes the switch if you have enough current. The base resistor here is calculated to give yourself enough current no matter what beta you might be having in your transistor. You want to essentially saturate this transistor. So when you make the input here go high, it saturates the transistor, which then draws current down through this inductor and closes the relay switch. When you then turn it off and lower the voltage here, put this input voltage to ground or low, that will make the transistor go into cutoff, which will stop the current from flowing through the transistor to ground. And if we didn't have this protection diode here, the voltage right here where all the current was going through would get very high, because the coil is an inductor and has some inductance, and V equals L di dt. So when you try to change the voltage the current instantly, the voltage gets very high here. And with the diode, it will limit it to 0.7 volts above VCC, which hopefully won't fry your transistor. The next circuit I'd like to look at is the VBE multiplier. It's an adjustable voltage reference that can be adjusted from 0.7 volts up to whatever you want, as long as it's not larger than the collector to emitter breakdown voltage of your BJT. There was a video previously that talked about this. We generally pick R1 and R2 so that the current in resistor R2 is much larger than the current in the base. The next circuit is a high-power Zener diode. Sometimes you have a Zener diode that's almost the right voltage, maybe a little smaller than you actually want, but it won't handle the power. It can't handle the current going through it. It will burn up. It's too much. Your need is for too much current. You can use an NPN bipolar junction transistor in this fashion right here to make a high-power Zener diode. Most of the current flows through the NPN transistor, and like 1 over beta of it approximately flows through the Zener diode. The Zener voltage is V Zener plus 0.7. Here we have a circuit known as an H-bridge. This H-bridge is often used to drive motors. The load is in the middle here, is marked with M, and often, as I said, it's a motor. And motors have a lot of inductance. Let's see how this works. If I make the forward input high and the reverse input low, then what will happen is the forward input will turn on this NPN transistor, and the reverse being low will turn on this PNP transistor. Therefore, current will flow from VCC down through this transistor, then through the motor in this direction, and back through the NPN to ground. If we do it the other way around, make the reverse high and the forward low, the current comes down through this PNP transistor, through the motor in the opposite direction, and down through this NPN transistor. The reason that these two inputs on the base are tied together and these two inputs here are tied together is that we never want to turn on two transistors simultaneously, there or there. The orange diodes here are protection diodes. They're essentially very similar to what we saw up here in the relay circuit. And they keep you from burning out these transistors because of the giant inductive voltage you get when you turn off the current in a motor, which is highly inductive. The last couple circuits are known as Darlington pairs. This one right here using two NPN transistors. You could also use two PNP transistors. And this one over here, known as a complementary Darlington pair, or Zlaki, because this Hungarian guy was the guy who made it popular. And you notice you have an NPN and a PNP, and you could also reverse the roles here as well, while reversing the current. So those are some handy bipolar junction transistor circuits.